Good afternoon, students. Good afternoon, Ashwin. So, am I visible and audible? Let me know, yes, if I am visible and audible. Let me know in the chat box or give me a thumbs up. Ashwin, can you be able to see me? Yes? Okay. So, today we'll continue with solutions lesson. So, we are dealing with mainly the colligative properties, right? So, there are four types: relative lowering of vapor pressure, elevation and boiling point, depression and freezing point, and osmotic pressure. So till yesterday, we have discussed the first three types, and today we are going to the fourth type of colligative property, which is called as osmotic pressure. Okay. So before moving on to the meaning of osmotic pressure, first let's start with osmosis. Okay. So I'll show you some pictures. Just observe that. So here, this is a mango, right? This is a mango, raw mango. And if I put this mango in a salt solution, NaCl solution is called as Brin solution. And if I put this mango in the salt solution, then it will be turning. The appearance of the raw fresh mango will be turned like this. Okay. And also if I take a flour, so this flour is not so fresh, no? So if flour is getting, when does a flour gets converted to new fresh flour? So when I add some fresh water to the one which is looking very old, it will give a fresh appearance. Okay. So what is happening in these two cases? So that's what we are going to discuss. Okay. So a mango is turning into what to say, a good, the fresh looking mango is turning into a bad looking mango if it is treated with a NaCl solution. The bad looking rose flower is or any other flower, it is getting converted to a fresh looking flower when some water is added into it. So what is the reason behind this? So that we will discuss here. Okay. Now, osmosis. What is osmosis? So it is the process of flow of solvent molecule through the membrane from pure solvent to the solution. Process of flow of solvent molecule through the membrane from pure solvent to the solution. Good afternoon, Jain V. Ramnagar students. Good afternoon, Pratyusha. Try to join on time, okay? Huh? No issues. So just I have just entered into the fourth type of colligative property, which is osmotic pressure. Okay. So now I'm discussing about osmosis. Got it? Now osmosis is the flow of solvent, yeah, through the membrane from pure solvent. So here you can see two membrane, two tubes. So this is nothing but the solve. This is nothing but osmosis. So let's see. So the first half is the solvent side. Okay. The first half is the solvent side. This is the solvent part and this is the solution part. And we have a membrane. We have a membrane at the middle, okay, which is separating the solvent and the solution cube. So that membrane is called as semi-permeable membrane. It is called as the semi-permeable membrane in which some small holes will be there through which the solvent molecule will be flowing into the solution side. Okay, so process of flow of solvent molecule through the membrane from the solvent to the solution. So what is happening here when the solvent is moving towards the solution side? The solvent volume is getting decreased because it is moving towards the other side. Okay, so solution volume is getting increased. So this process is called as osmosis. This process is called as osmosis. Okay. Now, what is the role of this semi-permeable membrane? So here you can understand, right? So initially, solvent and the solution, they are in very equal amount. And as times goes on, so the solvent molecules are passing through the membrane and moving into the solution side. okay, in which the salt molecules are present. So here the flow of solvent is getting to the other side. This is called as osmosis. Now here, what is the role of this semi-permeable membrane in osmosis? It is the membrane which allows the molecule of the solvent only to pass through it, but not the solute molecule. Okay. So solute molecules will not be passed, only the solvent molecules can be passed through the semi-permeable membrane when the solvent and the solutions are separated by the membrane, and that is called as semi-permeable membrane. Okay, so in the solution we may have only the we may have solute and the solvent, but only the solvent will be passed through the membrane because very small holes will be there. Okay, so in which only water molecules can pass through it. So that is called a semi-permeable membrane. So you can see the osmosis here in this picture also. So here we have a sugar solution in one container in which the piston is attached. And on the other side, we have the solvent molecule. So they are separated by a semi-permeable membrane at the middle. Okay. So now coming to the osmotic pressure, first of all, a vessel is divided into two parts like this by a semi-permeable membrane as shown the above figure. Okay, so in one part of the vessel, solvent is taken, and in the other part, solution is taken. The two parts are fitted with the piston. So who is this piston? Piston is the instrument which is used to give the pressure. So in both the container, you can see piston attached. Okay. Now the piston on the solution side moves up. So piston on the solution side is moving up due to osmosis. It is moving up due to osmosis. What is osmosis? The solvent molecules will be flowing into the solution side. So when it flows, the piston is going up, okay, because of the pressure. And if pressure is applied on the solution, and the piston is going upward in one side, and in the other side, we are applying some pressure. Pressure is applied on the solution, which is numerically equal to the osmotic pressure. The movement of the piston can be stopped. So one side the piston is going upward. Okay, one side the piston is going upward because of the flow of solvent to the solution side. Okay, and on the other side, what I am giving some pressure. If the external pressure which I am giving is equal to the pressure which is given by the solution, then we call that pressure as osmotic pressure. Okay, then the pressure applied on the solution side to stop the process, of osmosis. Is numerically equal to the osmotic pressure, and it is denoted by the letter phi. Okay, so let me repeat this once again. So osmosis, coming to osmosis, it is the flow of solvent molecule to the solution side. And because of this flow, the piston which is attached to the solution container, it is moving upward. Okay. And some external pressure is applied on this piston from the other side to stop the process of osmosis. And that pressure is equal to the osmotic pressure. Okay. Clear for all of you? Any doubt? Do any of you have any doubt from this part? Yes or no? Is everything clear? Pratyusha and Ramnagar students, do you have any doubts here? All of you have understood what is osmosis and what is osmotic pressure, right? Say something, say yes or no. Am I audible? Am I audible to you guys? Okay, thank you so much. So now let me go with the next slide. So osmotic pressure is nothing but the excess pressure that must be applied on the system to prevent the osmosis. Okay, applied to the system means the system is the solution. Okay, and this osmotic pressure is the colligative property. Okay, it is denoted by the letter pi, and we have one formula. So pi is equal to CRT, where C is the concentration, okay, in terms of molarity. So molarity means number of moles of solute divided by volume of solution in liters. Okay, so that is molarity. So the concentration term is given there in that form, and R is a universal gas constant and T is the temperature. So in place of C, in place of concentration, we can substitute N by V. Okay, here we have N2. So what does this 2 denotes? 2 denotes the number of moles of the solute molecule. Okay, 1 means solvent, 2 means solute. So in place of C, substitute N2 by D. Okay, and here R is a gas constant, T is the temperature in Kelvin, and we all also know that number of moles is equal to mass by molar mass. Mass of the solute divided by molar mass of the solute. And if we apply W2 by M2 in place of N2, we will get this formula. Okay, taking the volume to the other side. Now take this M2 to the other side and bring the pi V to the other side, to the denominator. We will end up with this kind of formula in which it is being used to find out the molar mass of the solute. So molar mass of the solute is equal to W2 into RT divided by pi into D. Okay, which is very, very important for solving the numericals. So this all the formulas. So here this one, everything is important. Depending on the question, we are going to apply the corresponding formula. Okay, so take down this. So all of you can able to understand, right? All of you can able to take out the M2 value from CRT, right? Say yes or no. Say yes or no. If you're having any doubt in this, just ask me. I'll repeat it again. Is everything okay? Clear? Okay, let me move on to the next slide. So we'll go with the uses of osmotic pressure. So it is the method which is used to determine the molar mass of the protein. Okay, molar mass of the protein, molar mass of the polymer, and the molar mass of some other macro molecule. Okay, so all macro means the molecules which is having the very large mass. Okay, so like protein, polymers, they will be having very high value of mass. Okay, so those molar mass, their molar mass can be determined only by osmotic pressure colligative property, not with other colligative property. Okay, and osmotic pressure method has advantage over other method also due to the pressure measurement which is around the room temperature. Okay, pressure measurement around the room temperature, and the molarity of the solution is used to instead of molality. Okay, here we are using molarity instead of molality because in place of C we are putting N by V, right? So this is the formula for molarity. So because of these two advantages, we are going for preferring for osmotic pressure colligative property. Okay. So now next I'm going to discuss about the isotonic solution. So what is meant by isotonic? So here we will be discussing three types of solution. The first is isotonic. Okay. Now, isotonic solutions are the solutions having same osmotic pressure. Suppose if I have two solutions, if let me take the first solution as 1 and second solution as 2. So the osmotic pressure of both the solutions are same. That is, if pi 1 is equal to pi 2, then those solutions are called as isotonic solution. Iso means same, right? So it is like this. And we know that pi is equal to, CRT. So R and T are the constant. Only the C value concentration will be changing. So pi 1 is equal to C1RT and pi 2 is equal to C2RT. Okay, now they are left hand side and right hand side, we are equating. So RT and RT will get cancelled. So we will have C1 is equal to C2. Okay, so no osmosis occurs between them. If the concentration of both the solutions are same, then the osmotic pressure is also same. Means osmosis will not occur between those solutions. So what is the example? What is the example for this type? So example is taken as 0.9 percentage mass by volume sodium chloride solution, which is isotonic with blood plasma. It is isotonic with blood plasma. Means if we place the blood cell in the sodium chloride solution, if we place the blood cell in the sodium chloride solution, three things will happen. Okay. First of all, if the solution concentration is more than 0.9 percentage of this mass by volume percentage, then what will happen? The water which is present inside the blood cell will go out of it. Okay, it will go out of it and it will enter into the solution. So if this is the case, then it is called as hypertonic solution. Okay, it is called as hypertonic solution. And if the blood cell is placed in the solution in which the concentration is equal to 0.9 percentage mass by volume, then the inlet and outlet will be same. The water which is coming inside and the water which is going outside. So those concentration will be same. And in that case, we are calling that as isotonic. The third case is if the concentration is less than 0.9 percentage, then what will happen? The water which is present in the solution will come into the blood cell and the blood cell will become, they will bulged out like this. They will become bulged out like this and we call that solution as hypotonic solution. We call that type of solution as hypotonic. So isotonic means in and out will be same. Okay. So hyper means water which is present inside the cell will go out and the blood cells will shrink. And hypotonic means the water which is present outside will come into the cell and the cell will become bulged out. Okay, that is hypotonic. So is this clear to all of you? This is very important. You might have studied this in your biology part also. Okay. Is this clear, students? Just let me know in the chat box if you understood everything. Have you understood all the topics that I have discussed now? Say something, say yes or no. Don't get scared. Just talk freely. If you're having any doubts, just ask me. I'm here to explain you. Okay. Yes. Fine. Okay, then I will move on to the next slide. Next, we will go with the effect and uses of osmosis. The effect and uses of osmosis. So here, this is called as edema. Okay, because of osmosis, a person will get a disease called edema. And here, if you see the roots, the water movements are there in the roots. And if you go for the salting of meat, there also osmosis occurs. Okay. So now we are going to discuss about the reverse osmosis. What is reverse? This is the opposite. If the pressure on the solution side is greater than the osmotic pressure, if the pressure on the solution side, this is the solution side, okay, this is the solution side. If the pressure on the solution side is greater than the osmotic pressure, then it is called as reverse osmosis. So the uses are desalination. Just look into this. This is reverse osmosis. So I am giving some pressure on the solution side and that pressure is greater than the osmotic pressure, because of which the particles are moving towards the solvent side from solution side. Means from higher concentration to lower concentration side it is moving. Okay. So this is called as reverse osmosis. Just see here. This is reverse osmosis. This is the solution part. Pressure is applied here. Because of the applied pressure, the concentration from higher thing, the particles from higher concentration is moving towards the lower concentration. This is reverse osmosis. This is the opposite of osmosis. In osmosis, particles will move from solvent to solution. In reverse osmosis, it will move from solution to solvent. That's all. Okay. The use is desalination of seawater. Desalination of seawater. And in our home also, we will be having this RO, no? Reverse osmosis. So here also the same thing happens. Okay. So just give me a minute. I will be back. Okay. Sorry for the thing. Just stay in the call. Give me a minute. I will be back. Just take down this. Okay. Sorry, my dear students. Yeah. Yeah. So this is a reverse osmosis. And do you have any doubts from the reverse osmosis part? Do any of you have any doubts from the reverse osmosis part? Shall I move on to the next slide? Shall I move on to the next slide, students? Yeah. Here I have got a question for you. Not only one question, I have some more questions also. So the first question is, what happens to the raw mango when it is placed in a concentrated salt solution? So initially I have shown you one picture, right? The first picture. So the raw mango when it is placed in a concentrated salt solution, which is called as Brin solution. I have showed you, no? So Brin solution. So if I am placing that raw mango inside that concentrated salt solution, something will happen. What is that something? What is happening there? Actually, it loses the water through osmosis process and it is getting converted into a pickle. So this is the picture I have shown you at the beginning now in the first slide. So the raw mango loses the water. Water is a solvent. So water is getting out through osmosis process and it is getting converted to a pickle. So the Brin solution is called as concentrated salt solution. Okay, clear. Now the next question is, what happens to the wilted flowers when placed in fresh water? So I have shown this picture also in the beginning. So the wilted flowers, when they are placed in the fresh water, they get revived due to osmosis. They are getting revived due to osmosis. So this is the picture now which I have shown you. So the wilted flowers are getting revived due to the osmosis process again. Okay, so they are observing the solvent molecules here. In the previous case, they lost the water and here they will observe the water. And also if you see some vegetable vendors, okay, so they often keep sprinkling water on the vegetables to keep them firm or turbid. Why? Have you ever seen vegetable vendors sprinkling the water on the vegetables on the in the shop? So they do that to keep the vegetables firm and turbid. Okay. So what is the reason for sprinkling that water on the vegetable? Any idea? Do any of you have any idea about this? Why they are sprinkling the water? Why they are sprinkling the water? So, okay, I'll tell you. So the vegetables are exposed to air. Okay, so vegetables which are being exposed to air, they lose their water from the cells. Vegetables will lose the water from the cells because of the exposure to air. So when the water is sprinkled on that vegetable, they will take back the water which we are sprinkling through the osmosis process. That is absorption of solvent molecule is again taking place there, and the vegetables are getting revived. Okay. So is this clear now? Did you all get it? Do you have any doubts from this? Do you have any doubts from the reason for sprinkling water on the vegetables in the vegetable shops? Now it is clear, no? All of them are due to osmosis process. Okay, fine. So we will go with some numerical problems here. The first question is, if 10 gram of an unknown non-electrolyte substance is dissolved to make 500 ml of solution, then osmotic pressure at 300 Kelvin is observed to be 1.23 atmospheric pressure. Find the molecular weight of the substance. Now, how to approach this problem? What is the solution? So, we are asked to find out the molecular weight. M2 we have to find out. It is the substance, which is nothing but the solute. So, it is M2. And from the osmotic pressure concept. So, obviously, we have to use pi is equal to CRT formula. And what other informations are given in the question? We have volume, okay, in terms of milliliter, and we have temperature in Kelvin, and we have the osmotic pressure value also. Pi value is also given. So pi is equal to 1.23 atmospheric pressure, and concentration is nothing but number of moles by volume of solution in liter. So what I can do? C is equal to, so pi will be equal to number of moles divided by volume into RT. Okay. So now from this is the concentration. Number of moles can be written like this, and the C value will be 10 into 1000 divided by M2 into 500. So here I can still simplify this to get, this is N2, right? So mass of the solute divided by molar mass of the solute into volume. Here already we are having R and T. Okay, so you can put all the values here. So W2 is the mass of the solute and it is 10 gram. This is given in the question. And R into T divided by M2 into B. Okay, so volume is given as 500 milliliter, but we have to substitute here the volume in terms of liter. So that's why we are putting 1000 in the numerator. So denominator of the denominator actually goes to the numerator, and we are getting this, and temperature is 300. Temperature is 300, and substitute everything into the formula, into this formula, you will get this. Okay, pi is 1.23, 10 is the mass of the substance. So M2 we have to find out. So this is the volume, this is the R value, and this is the temperature. So if you cross multiply, if you do the multiplication and division, you can get the answer. Has anyone got the answer here? So here if I calculate, I will get 2 and 600, 6,000 into 0.0821 divided by 1.23. Has anyone got the answer for this question? Has anyone solved? Do any of you have solved this, students? Okay, do the multiplication part and division part and check whether you are getting 400.48 gram per mole as the answer or not. Okay, so just this, it is a direct substitution. Okay, it is a direct substitution. You don't have to worry about the concepts. Only one formula is being used and the rest all are with multiplication and division. Okay, so here is the first question. Coming to the next numerical. Yeah, it says that 200 cc, cc means cubic centimeter, okay, of an aqueous solution of protein contains 1.26 gram of the protein. So the protein mass is given. Okay, 1.26 gram means it is the mass of the protein. The osmotic pressure of such solution at 300 Kelvin is 2.57 into 10 power minus 3 bar. So this is the osmotic pressure value. Find the molecular mass of the protein. So M2 is asked. How to find out? Osmotic pressure is given. Okay. Volume is given in terms of cubic centimeter. Okay. This is the volume value, cc. So it can be converted to liter like this. And if you multiply this by 10 to the power minus 3, the cc will be converted to liter. Okay. And the temperature is given as 300 Kelvin. Now take our formula, M2 is equal to W2 RT by pi V, in which R value is a constant, right? So in terms of bar liter, R value will be written like this. 0.03 is the constant for R, which you have to use in, if the other terms are in bar. Okay. Now on substituting everything, M2 is equal to substitute the mass value and all the R, T value, pi and V value. So if you do this, you will get M2 as 610.389 gram per mole. Very easy. Only thing is that we have to concentrate on the multiplication. Okay. We may know the formula, we may know how to apply this, we may know everything. But if we make a mistake in multiplication or division, that is, if we make any mistake in this mathematical part, then we will not arrive at the correct answer. Okay, so here in physical chemistry, you should be very, very, very careful in doing the maths. Okay, so here chemistry, both chemistry and maths, both are very important. Concept as well as the mathematical part is important. Okay, you may know the formula, but you have to substitute and do all the calculations correctly. Then only we can pick out the correct answer. Okay, so it is not like other chemistry, like inorganic or organic. So here you have to do it carefully. Okay, clear students? Do you have any doubt from this question? You will be able to take out the given values and you will be able to do all the multiplication division so easily, right? So shall I move on to the next question for you? Yes or no? Shall we go with the next question? Yes. An aqueous solution containing 6 gram urea. An aqueous solution of 1 liter is contained 6 gram of urea and its molecular weight is given. Its osmotic pressure is found equal to the solution of glucose. How much weight of glucose is present in 1 liter of the solution? Molecular weight, volume, everything is given. We have to find out the weight of glucose. That is the mass of glucose we have to find out. So let me take the formula in which pi v is equal to W to RT by M2. And here we have two solutions. One is an aqueous solution. The other one is a glucose solution. The other one is a glucose solution. And here, aqueous solution volume is also 1 liter. Glucose solution volume is also 1 liter. So volume remains same. Okay. And also if you see the molecular weight, urea is having urea solution is having 660 and glucose solution is having 180. Okay. Now both are having the same osmotic pressure also. Osmotic pressure is found equal. Is found equal for both the solution. So here pi 1 is equal to pi 2. If osmotic pressure is same, if osmotic pressures are same, then pi is directly proportional to T, right? Pi is directly proportional to T and temperature will also be same. T1 will also be equal to T2. And also volume, V1 and V2. So volume also remains same for both. So since pi 1 is equal to pi 2, T1 is equal to T2 and V1 is equal to V2. Okay. And the mass of urea is given. Mass of the urea. I'm taking urea solution as 1. Okay. So W1 is given as 6 gram. And we have to find out the mass of the glucose. That is, we have to find out W2. W1 is 6 gram. W2 is being asked. So how to find out W2? W2 is equal to 6 into 180 divided by 60. So pi, temperature, volume. We are not going to consider all these things. We are going to consider only this part. Okay. The other things are constant. So W2 divided by M2 is equal to W1 divided by M1. Okay. W2 divided by M2 is equal to W1 divided by M1. So now W2 is equal to W1 is 6. If you take this M2 to the other side, what is the M2 value? Molar mass of glucose, it is 180 divided by M1. Molar mass of urea is 60. Okay. So here we can cancel all these things and we are arriving at the value 18 gram. Okay. So 18 gram is the mass of or the weight of glucose present in 1 liter of the solution. Clear? Able to understand? You are able to understand or not? Shall I repeat or shall I move on to the next question, students? I hope it is clear. But if you have any doubt, just let me know in the chat box. Shall I proceed with the next question? Is everything clear so far? Give me a quick response. Give me a quick response. I'm audible now? Am I audible? Yeah, I'll move on to the next question. During osmosis, the flow of water through a semi-permeable membrane is the flow of solvent. Water is nothing but the solvent through the semi-permeable membrane is what? It will be from both sides or with equal rate or with from both sides with unequal rate or from solution having low concentration or from solution having high concentration. During osmosis, the solvent molecules are going from the low concentration to high concentration value. Okay. So option C is the correct answer for this. During osmosis, the flow of solvent is through a semi-permeable membrane that is from lower concentration to higher concentration value. Clear? Now we'll go with the one more question. A solution containing 10 gram decimeter cube, decimeter minus power minus 3 of urea is isotonic with a 5% solution of a non-volatile solute. The molecular mass of this non-volatile solute is. So here we have to use pi B is equal to nRT formula. Okay. So where pi is equal to nRT by B. nRT by B. Okay. So what it is? It is equal to, so what is the number of moles? The number of moles can be written as mass by molar mass. So the mass is 10 and the molar mass is 60. Okay. So into R value is 0.0821. Okay. Into temperature. Into the temperature. Okay. So 1 decimeter cube is nothing but 1 liter. This is nothing but 1 liter. So the volume is taken as 1 liter. So I can put that volume at the denominator. I can leave that also. Okay. And also we have one more relation which is 5% solution. What is meant by 5% solution? It means 5 gram of the solute is dissolved in 100 ml of the solution. This is the meaning of 5% solution. Okay. 5 gram means 100 ml. If it is 50 gram, if it is 50 gram per liter means it will be in 1000 ml. No, it will be 1000 ml. Okay. So now the osmotic pressure of the solution having non-volatile solute, which is pi 2. Okay. Non-volatile solute is equal to 50 divided by the molecular mass into 0.0821 into temperature. Okay, so let me show everything in a single picture for you. So here is the concept. Now for isotonic solution, the osmotic pressure will be same. So phi 1 will be equal to phi 2. So what will happen here? We have to equate these two. So this is the first first solution osmotic pressure, and this is the value of second solution osmotic pressure. So equate those two. Okay, equate those two and get the answer for M2 molecular mass of non-volatile solute as 300 gram per mole. Okay, so option A will be the correct answer. Clear for all of you? It is given that the solutions are isotonic. First one is having 100 gram, 10 gram and 60, 10 gram of the substance, in which the molecular weight of the substance is 60 gram, and that particular solution is isotonic with 5% solution of a non-volatile solute. So we are equating those two and getting the value of M. Okay. So R value, T value, nothing to do with those things. So PT will get cancelled and R also will get cancelled. Okay. And here we will have 5. So if you take this to the other side, you will get 300. That's all. Okay. 5 into 60 is 300. Very easy. So moving on to the next question. Blood cells retain their normal shape in solution, in which case the blood cells retain their normal shape, in which case they will either shrink or it will neither get bulged out. Only if they are put inside the isotonic solution, right? Because in that solution only the flow of water molecule inside the cell and the flow of water molecule outside the cell will remain same. So the blood cells will maintain their or they will retain their normal shape. Okay, so option B is the correct answer here. Moving on to the last question for today's session. So here I have a question. If 0.1 molar solution of glucose and 0.1 molar solution of urea, if they are placed on two sides of the semipermeable membrane to equal heights, then it will be correct to say that. So we have two solutions, solution of glucose, solution of urea. Both of them are having the same concentration and they are placed on two sides of the membrane. Then which among the following four options is correct to say for this given statement? C1, concentration of the first solution is equal to the concentration of the second solution. Means there will be no net movement across the membrane. There will be no net movement across the membrane because it is an isotonic solution. Since the concentrations are equal, it is the isotonic solution. So there will be no net movement across the membrane. Okay, clear? Clear for all of you? Okay, students, so here the osmotic pressure topic is getting over. Okay, so I hope the session is clear, very clear and useful to all of you guys. And if you're having any doubts from the fourth colligative property, which is the last colligative property, that is osmotic pressure, you can ask me now. If you're having any doubts, you can ask me. Do any of you have any doubts from the property that we have discussed today? No doubts? Okay then. Thank you so much for listening to today's lecture, students. Thank you. Take care. Bye-bye. See you all in the next session. Okay? Bye.